Hello everyone and welcome to the IT-KnowledgeBase YouTube channel, your ultimate destination for IT tutorials, troubleshooting guides, and in-depth tech insights. Whether you are an IT expert looking for advanced solutions or a beginner seeking to build a solid foundation in information technology, we have got you covered. Our channel offers step-by-step guides, review of the latest tech trends, and practical tips to help you stay ahead in the ever-changing IT landscape. Subscribe for regular updates and never miss out on essential IT knowledge. In today's video, we are diving deep into the world of networking, where we'll equip you with the essential skills to enhance your networking expertise. If you have ever wanted to master the intricacies of VLANs, DHCP, Inter-VLAN routing, and static routes, you are in the right place. Networking is the backbone of modern IT infrastructure, and understanding how to configure these critical components can set you apart in your career. We'll be using pfSense, a powerful open source firewall and router, to demonstrate how to effectively manage and secure your network. In this video, we'll start by breaking down the concept of VLANs and how they can help you segment your network for improved performance and security. Next, we'll explore the DHCP and learn how to automate IP address assignment to VLANs, making network management a breeze. But that's not all. We'll also cover inter-VLAN routing, which allows communication between different VLANs, and we'll set up a static routes to ensure efficient data flow across your network. By the end of this video, you'll have a comprehensive understanding of these concepts and the practical skills to implement them using pfSense. So whether you are a networking novice looking to build a solid foundation or an experienced professional aiming to refine your skills, this video is tailored for you. Let's get started and take your networking skills to the next level. Okay, I'll give you a brief explanation of the present network scenario. The key component of this network illustrates the configuration of VLANs, DHCP, inter-VLAN routing, static routes, and the pfSense firewall. This diagram serves as a visual representation of how these elements interact to create a robust and efficient network. Number one is VLAN, Virtual Local Area Network. At the core of our network design are the VLANs. Each VLAN is represented as a separate segment within the diagram, allowing us to logically group devices based on functions, departments, or security requirements. For example, we have a VLAN 1 is the default native VLAN untagged traffic. I am using this port for my management PC in my IT department, and it is safe to connect to a switch port and gain access to my management network. VLAN 10 is a separate segment for my HR team, and VLAN 20 for the accounts team. And we have a remote office for other groups, which is not on the VLAN but a separate network. By segmenting the network into VLANs, we enhance security and reduce broadcast traffic, ensuring that devices only communicate with those in the same VLAN unless routing is configured. We configure VLAN in our Cisco switch and then add those VLANs in the pfSense firewall to create a separate interface and traffic. Then we will create a DHCP for separate VLAN interfaces responsible for dynamically assigning IP addresses to devices within each VLAN. This simplifies network management by automatically providing devices with the necessary configuration settings, such as IP address, subnet mask, gateway, and DNS servers. Each VLAN will have its own DHCP scope, ensuring that devices receive IP addresses from the correct range. For instance, VLAN 10 might use the range 10.10.10.100 to 10.10.10.200, and VLAN 20 might use the range 10.10.20.100 to 10.10.20.200. Next is inter-VLAN routing. To enable communication between different VLANs, we have configured inter-VLAN routing, which is typically handled by the pfSense firewall. In the instance, you'll see that the pfSense device has interfaces assigned to each VLAN. This setup allows devices in one VLAN to communicate with devices in another VLAN while maintaining security policies. The pfSense firewall maintains a routing table that directs traffic between VLANs, ensuring that data packets reach their intended destinations. Number 4. Static routes. In addition to inter-VLAN routing, we may have static routes configured within the pfSense firewall. These routes are manually defined paths that direct traffic to specific networks or devices outside the local VLANs. For example, if we have a remote office or a specific server that needs to be accessed, we can set up a static route to ensure that traffic is routed correctly. A static route might be configured to direct traffic destined for a remote network, for example 10.10.30.0/24 through a specific gateway. Number 5. pfSense Firewall. The pfSense Firewall is a critical component of our network, providing security and management capabilities In this illustration, you'll see it positioned at the network edge, where it controls incoming and outgoing internet traffic. We can also define firewall rules to allow or deny traffic between VLANs, ensuring that sensitive data is protected while still allowing necessary communication. In conclusion, this network diagram encapsulates the essential elements of a well-structured network using VLANs, DHCP, inter-VLAN routing, and static routes with pfSense. By understanding how these components interact, you can effectively manage and secure your network, ensuring optimal performance and reliability. Okay, let's start creating our VLANs first in our Cisco switch. Open switch number 1 and then go to global configuration mode. Create an associated VLAN 10 and name this VLAN to HR. Now create another VLAN, that is VLAN 20, which does not exist on this Cisco switch but does exist on another switch number 2. This is vital for trunk to extend VLANs across the network. Otherwise, it won't work. A frame of VLAN 20 goes from switch number 2 to switch number 1. It must exist in switch number 1 with a VLAN tag 20. That means the switch number 2 port must be tagged on VLAN 20. It must be entered in switch number 1. To do that, you must tell switch number 1 to accept traffic with the VLAN tag of 20. Now add both interfaces Ethernet 0/2 and 0/3 in VLAN 10. I am following my diagram and you should follow yours. In global configuration mode, type interface. Ethernet 0/2. Switch port access VLAN 10. Add this interface to VLAN 10. Now add another interface, that is Ethernet 0/3. Interface Ethernet 0/3. Switch port access VLAN 10. We have created a VLAN in switch number 1 and added the interfaces. Check the VLAN status. Do show VLAN. Here is my VLAN 10 and my Ethernet interfaces. Now open the switch number 2. And then go to global configuration mode. Create an associated VLAN 20 and name this VLAN to accounts or whatever you like. Now create another VLAN, that is VLAN 10, that does not exist on this Cisco switch but does exist on switch number 1 for trunk to extend VLANs across the network. Otherwise, it won't work. Now add both interfaces Ethernet 0/2 and 0/3 in VLAN 20. In global configuration mode, type interface Ethernet 0/2. Switch port access VLAN 20. Add this interface to VLAN 20. On this interface, type description account. Now add another interface, that is Ethernet 0/3. Type interface Ethernet 0/3. Switch port access VLAN 20. Add this interface to VLAN 20. Type do show VLAN. We have created a VLAN in switch number 2 and added the interfaces. Now configuring a trunk port on the interface is an essential step in setting up VLANs on a network switch. A trunk port allows multiple VLANs to traverse a single physical link between switches or between a switch and a router or firewall, such as pfSense. Here is a step-by-step how to configure a trunk port along with explanation of the key concepts involved. Enter a global configuration and configure the trunk port. Select the interface. In my case, it's interface Ethernet 0/0. Set the port to trunk mode. Switch port mode trunk. If you encounter the error message, command rejected, an interface whose trunk encapsulation is auto, cannot be configured to trunk mode, You can try these steps to fix it. For multi-layer switch, you must first set the trunk encapsulation type. Type switch port trunk encapsulation .1q and then repeat the same command earlier. Switch port mode trunk. Hit enter. Perfect. Now allow specific VLANs for management purpose. By default, a trunk port allows all VLANs. If you want to restrict the trunk to specific VLANs, you can use the following command. Switch port trunk allowed VLAN 10, 20. We only have two VLANs, 10 and 20. Replace 10 and 20 with the VLAN IDs you want to allow on the trunk. Set the native VLAN, it's optional. The native VLAN is the VLAN that is untagged on the trunk link. By default, this is VLAN 1. Switch port trunk native VLAN 99. Replace 99 with the desired native VLAN ID, but we are not going to change it, so we will leave it as it is. Now save the configuration. Exit from the global configuration mode. Type exit. Save your changes to the switch startup configuration to ensure they persist after a reboot. You may also type copy running configuration to startup configuration. Hit enter. Hit enter. It's saved. Verify the configuration and check the trunk status. Use the following command to verify that the port is configured as a trunk and to see the allowed VLANs. Go to privilege mode, type show interfaces trunk. Hit enter. Here is my trunk interface. You can also check the VLAN configuration with show VLAN brief. We have configured the trunk interface on switch number 2. We have successfully configured the trunk interface in switch number 2. Now switch back to switch number 1 and perform the same practice to make the interface a trunk. In switch number 1, we have two interfaces that are required to configure the trunk port or interface. Ethernet 0/0 that connects to switch number 2 and Ethernet 1/1 that interface connects to the pfSense LAN interface. Let's configure the Ethernet 0/0 first. Enter global configuration mode and configure the trunk port. Select the interface, type interface Ethernet 0/0. Set the port to trunk mode, type switch port mode trunk. If you encounter the error message, command rejected, an interface whose trunk encapsulation is auto, then for multi-layer switch, you must first set the trunk encapsulation type. Type switch port trunk encapsulation and .1q. Hit enter and then repeat the same earlier command. Switch port mode trunk. It should work perfectly. Now allow specific VLANs for management purposes. By default, a trunk port allows all VLANs. If you want to restrict the trunk to specific VLANs, you can use the following command. Type switch port trunk allowed VLAN 10 and 20. We only have two VLANs, 10 and 20. Replace 10 and 20 with the VLAN ID you want to allow on the trunk. Now set the native VLAN, it's optional. The native VLAN is the VLAN that is untagged on the trunk link. By default, this is VLAN 1 if you want to change it. Switch port trunk native VLAN to 99. Replace 99 with the desired native VLAN ID, but we are not going to change, so we will leave it as it is. Now the second interface is interface Ethernet 1/1. For multi-layer switch, again, you must first set the trunk encapsulation type, switch port trunk encapsulation .1q. Set the port to trunk mode, switch port mode trunk. Allow specific VLANs for management purposes. Switch port trunk allowed VLAN 1. This is my native VLAN 10 and 20. Hit enter. Exit from the global configuration mode and now save the configuration. Save your changes to the switch startup configuration to ensure they persist after a reboot. Type WR for write or copy running configuration to startup configuration. Go to privilege mode. Now verify the configuration and check the trunk status. Use the following command to verify that the port is configured as a trunk and to see the allowed VLANs. Type show interfaces trunk. Here is my trunk interfaces. You can also check the VLAN configuration with show VLAN brief. Here is my VLANs and the interfaces. There is no specific trunk mode setting in the pfSense. You just assign the VLAN to a NIC ports and it's done. Then configure those VLANs interfaces as usual. In conclusion, configuring a trunk port is a crucial step in managing VLANs within your network. By allowing multiple VLANs to share a single physical link, you can optimize your network's performance and organization. Remember to verify your configuration and ensure that both ends of the trunk link to both switches, switch number 1 and switch number 2, and then switch to the router. In this case, our pfSense Firewall is configured consistently to avoid connectivity issues. Here we have completed all the required switch level work in both switches. Okay, now open the pfSense Firewall to configure VLANs. Let me open to my Windows 10 PC. Log into my pfSense. First create the VLAN. Go to Interfaces. Click on Assignments. And then click on VLAN tab. Click on Add. Select the LAN interface. And add our first VLAN tag, which is 10. And the description. This is for HR. And then click on Save. Now add the second VLAN. Click on Add. Select the LAN interface. And add our second VLAN tag, which is 20. Description is accounts, and then click on Save. Here we have created the VLANs. Now add the VLAN interfaces. Click on Interface Assignment. In the available ports, select your newly created VLAN tag. Add VLAN 10. And then click on Add. Again select VLAN 20. And then click on Add again. Now click on Save. A new optional interface has been added. Now configure VLAN interface's IP address and subnet mask. Click on Opt 1 or VLAN 10. Enable the interface. Rename the description. Type V10 for VLAN 10 for HR. In the IPv4 configuration type, select static IPv4 and provide the IP address. In my case, this is 10.10.10.1. Select the 24-bit subnet mask and then click on Save. Click Apply Changes. Repeat the same practice for the second VLAN. Click on Interface Assignment. Click on Opt 2. Enable the interface. Rename the description to V20-ACCT for my accounts department. In the IPv4 configuration type, select static. Scroll down and provide the IP address. 10.10.20.1. Subnet mask is 24-bit. And then click on Save. Click on Apply Changes. Now configure the firewall rules. Click on Firewall. Then click on Rules. To create the firewall rule for our VLAN interfaces, select the VLAN 10. Click on Add. Action is Pass. The interface is VLAN 10. Address family IPv4 is fine. Protocol select to any. The source and the destination are set to any is fine. Type the description. Should speak about what is rule is about. I would type allow all traffic. And click on Save. Now create the same firewall rule to allow traffic on VLAN 20 interface. Click on Add. Action is Pass. The interface is VLAN 20. Address family IPv4 is fine. Protocol set to any. Source and the destination are set to any is fine. Type the description, allow all traffic, and then click on save and apply changes. Now configure DHCP on VLAN interfaces. This is completely optional. You may specify static IP to all your devices. But in my case, to make it easier, I would prefer to configure DHCP to provide complete IP address settings to all my PCs within their respective network. Click on Services, then DHCP Server. Click on VLAN 10. This is for my HR team. Click on Enable DHCP Server on this interface. You have this available range on this interface. In my case, I would provide the range 10.10.10.100 to 10.10.10.200. Scroll down. We don't need VINs. Just provide the DNS server. I would prefer to give my domain controller IP address for internal and external name resolution. My internal domain controller IP is 10.10.10.201 and 10.10.10.202. Scroll down and provide the gateway. Type the gateway. Typically, we don't need to specify here. It opted interface IP address automatically, or you could specify manually. In my case, I would specify 10.10.10.1. This is my gateway. It's up to you, or choose none for no gateway assignment. Scroll down and click on save. Repeat the same practice for the second VLAN 20. For accounts department, click on enable DHCP server on this interface. This available range 10.10.20.100 to 10.10.20.200. Scroll down. We don't need VINs, just provide the DNS server. I would prefer to firewall IP to forward external DNS queries. 10.10.20.1. Scroll down. Type the gateway. Typically, we don't need to specify here. It opted interface IP address automatically, or you could specify manually. 10.10.20.1. This is for my VLAN 20 interface IP address. Scroll down and click on save. Here we have completed our pfSense Firewall side job. This also configure Inter-VLAN routing because both VLAN gateways are pfSense firewalls, and we have created a widely open firewall rule to allow all traffic. This will allow all traffic between the LANs and the VLANs. Now it's time to check our configuration. We have concluded all the prerequisites to design and secure our network. To ensure that our configuration of VLANs, DHCP and Inter-VLAN routing is functioning correctly, we will conduct a series of tests, including verifying VLAN assignments, checking DHCP address allocation, and testing connectivity between devices across different VLANs. Open PC2 and then PC3 one by one to check if they have assigned network settings from the DHCP server running on the pfSense firewall. Open PC number 2. Type IP DHCP. Hit enter. To perform the DORA process, discover, offer, request, and acknowledge is a 4-step method used by DHCP or Dynamic Host Configuration Protocol to assign IP addresses to device on a network. Now type show IP and verify the DHCP assigned IP address settings. Everything seems to look very pleasing. Now check on PC2. Open PC2, type IP DHCP, hit enter to perform the DORA process. And now type show IP. Hit enter and verify the DHCP assigned IP address settings should be in the same range. Now check the same settings on the VLAN 20 side. Open PC number 4 and then PC number 5 one by one to check if they have assigned network settings from the DHCP server running on the pfSense firewall. Open PC number 4. On the VLAN 20 side, type IP DHCP. Sorry about the typo. Type IP space DHCP. Hit enter to perform the DORA process. Now type show IP and verify the DHCP assigned IP address settings. Everything seems to look very pleasing here. Now check on PC number 5. Open PC number 5. Type IP space DHCP. Hit enter. It's performing the DORA process. Now check the IP address settings. Type show IP and hit enter. And verify the DHCP assigned IP address settings should be in the same range. Now from the VLAN 20 side, Ping to VLAN 10 site. First verify the IP address on PC2. It's 10.10.10.100. Go to VLAN 20 site. It's 10.10.20.101. Type ping 10.10.10.100 on PC2 on VLAN 10 site. Hit enter to check the connectivity, and yes, it's also working fine. Now check the same from the VLAN 10 site. Go to VLAN 10 site and perform the ping to 10.10.20.101 to PC5 on the VLAN 20 site. Hit enter. It's working fine. Now go back to our pfSense Firewall and check IP leases to our DHCP clients. Go to status and then DHCP leases. Here you may check the IP leases to DHCP clients residing in VLAN 10 and VLAN 20. Now our internal VLANs IP address assigned to VLANs via DHCP and Inter-VLAN routing, everything is working splendidly. Now I would like to give you a precise brief on static routing. Imagine you have a pfSense router set up in your office network which is connected to various internal switches and VLANs. However, you also need to access a remote side router located in a different network that is not part of your internal infrastructure. To enable communication with this remote router, you will need to configure a static route in your pfSense, and this involves two steps. First, identify the remote network, determine the IP address and subnet of the remote network that you need to access, and that is 10.10.30.0/24, and then configure the gateway. Before adding a static route in the pfSense firewall, you must define the gateway that connects to the remote router. This is typically the IP address of the router on the local network that can reach the remote site, and that is interface Ethernet 1/0 with the IP address of 10.10.1.2/24. We have to make certain that we have properly configured R2 earlier. R2 has two interfaces. One is connected to our local network and the second interface is connected to the remote site network. Open the R2 and verify the configuration in the privilege mode. Type show running configuration. Hit enter. To check the configuration of both Ethernets, Ethernet 1/0 and Ethernet 1/1. As this is a recently deployed router on our remote site, and we are liable for managing and configuring the interfaces. So let's quickly configure the interfaces. Go to global configuration mode and type the first interface. Interface Ethernet 1/0. This is towards to my LAN interface. Type IP address 10.10.1.2. Subnet mask 255.255.255.0. Duplex is full and no shirt. Wait for a few seconds so the interface state should be up. The second interface is Ethernet 1/1. This is my remote site network. Type IP address 10.10.30.1. 255.255.255.0. Duplex is full and no shirt. Wait for a few seconds so the interface state should be up. Now type show running configuration to check the configuration of both Ethernets. Ethernet 1/0 and the Ethernet 1/1, and both are configured accurately. Don't forget to save the configuration. Now open the secure PC at a remote office site and verify the IP address settings. Type show IP. And this PC is manually assigned IP address 10.10.30.10/24 network. All the configuration on the R2 side and our remote office side have been completed. Now switch back to our pfSense firewall to configure static routes. In the pfSense, navigate to System, click on Routing. First we have to create a gateway before specifying the static route. Click on Add, select the interface LAN. Address family IPv4 is fine. Type the gateway name, mine is remote office, and type the gateway IP. In this example, our R2 LAN side interface is 10.10.1.2 and the description is remote office. Then click on Save. We have added our gateway. Click on Static Routes tab and then click on Add to create a new static route. Enter the destination network, which is 10.10.30.0, and the subnet mask is 24/24-bit. Specify the gateway we have created earlier, it's remote office. Optionally add a description for clarity. This route is for remote office site. Type remote office and then click on Save. Click on Apply Changes. Next, verify the firewall rule. In our pfSense, allow traffic to and from the remote network. Click on Firewall. Click on Rules. On the LAN side, I will specify widely open rule for the sake of testing and demonstration. Later, we could perform and impose more restrictions to allow only certain traffic. You could create specific rules that permit traffic only from your internal network to the remote network. Now, testing the connectivity. After the configuring the static route and firewall rules, test the connectivity by pinging an IP address in the local or internal network to the remote network. This will confirm that the routing is set up correctly. Now open the CMD and type ping space 10.10.30.10. This is the IP address of the remote site secure PC. Hit enter. I am getting ICMP replies. Now check the same network connectivity from the remote site. Open the secure PC and then type ping space 10.10.1.10. This is the IP address of my Win10 PC1 on my VLAN 1 site. Hit enter. And yes, network connectivity to and from the local and remote site office is working splendidly. Okay, now let's summarize. We have successfully configured our local network with VLANs, DHCP and Inter-VLAN routing using Cisco switches, routers and pfSense Firewall. Additionally, we established a static route to a remote site, allowing our internal network to communicate with an external router. This setup ensures efficient traffic management within our organization while providing necessary access to the remote resources. Alright, that is all for the now. Thank you for watching and I look forward to sharing more of my journey with you all. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Or if you have any issues or questions, you can reach out to me and I'd be happy to help you out. Thank you.